Okay, let's make a start. So today we're going to talk about the project. I'm going to give you a background of what the project tasks are going to be, some of the deadlines that you have. I'm going to give an example of one of the previous systems. Okay, the project's a fairly major part of this class, as classes go like this. So it is something to actually care about, and you do have to work on the project during the semester. I know that you're all CMU students, and therefore you're really good at doing things between 2 a.m. and 8 a.m. when the deadline is, but there's probably too much to fit in that 6 hours. So you should try to organise yourself to at least have some other 2 to 6 a.m. times during the semester. Okay? We're going to get you to build a question system and an answer system. This is a little different from some of the other question answering systems that are out there, okay? And so you should be aware of that. You go, oh, question answering, I'll go and look that up, we'll go and download IBM Watson and everything will be fine. And the answer is no. Well, one is, you're not allowed to download IBM Watson because then IBM will get the grade at the end rather than you, because you have to develop it. But IBM Watson wouldn't solve that problem because that's not really what they do. What we're going to do is we're going to give you a Wikipedia article, okay? Actually, we give you a bunch of Wikipedia articles. But the fundamental problem, we give you a Wikipedia article, and you have to generate questions which can be answered by that Wikipedia question. Okay, so you've got this article, describe something, and you have to generate questions from it. You might say, why would I do that? What's the point of doing that? It's part of the project, but apart from that, if you're trying to do exam questions, if you're trying to actually find out whether people understand things, question generation is a subject in itself. Okay, so you get this article, you ask a bunch of questions, they should be relevant to the article, they should have answers in the article, not just relevant about the article. Okay. And the second thing that we're going to do is we're going to give you an article, okay, and we're going to give you a number of questions. I think you can guess where the questions came from, okay, from the first part, and you have to answer them. So you have a bunch of questions which a machine thought could be answered in the article, and you have to try to answer them, okay? And it's fairly obvious. Now, what makes this different from other standard question answering systems is you don't know the article beforehand. Okay? Most other question answer systems are trained from lots and lots and lots and lots of existing question answers and data, all of Wikipedia. But no, you're not going to do that because you won't have enough time to be able to train everything on Wikipedia. You're going to get given this new novel article, and you have to generate questions. You're going to give the same or similar article with questions, and you're going to have to be able to answer them. Okay? So let's talk a little bit about types of questions. What is a good question? Okay, and so here's an article about Pittsburgh. Okay, I'm assuming you all know something about Pittsburgh. Okay, but more importantly, we have an article here that talks about Pittsburgh. So imagine this was the article we're actually dealing with. Could somebody give me an example of a question which can be answered by this article?
How much is the population in Pittsburgh?
Right. So what's the population of Pittsburgh? And within here, it says the population at some amount of whatever the combined statistical area. Do you need the combined statistical area? 2.6 million-ish people. Okay? That answer is in there. It's not exactly in there, and it doesn't say the population of Pittsburgh is number. Okay? But the information's there. And that's something that should be feasible to be able to answer. Can somebody give me another question which this has an answer for?
What is Pittsburgh famous for?
What is Pittsburgh famous for? And somewhere in here is Pittsburgh is known as a steel city, and it's more than 300 steel really, but it says known, it doesn't say famous, but there's sort of related words, and you should be able to try to work out the similarities between them. And so that's a good thing to try to do, okay? So there's a bunch of things that we can actually get out there, but notice what you're doing. You're looking for patterns in the text, and then you're trying to take these patterns and change them into a question. that's what you should be doing with your machine as well. So it's actually looking for these patterns and trying to replace them. So things like, where is Pittsburgh? What's the population of Pittsburgh? What's Pittsburgh nickname? How many steel-related businesses are in Pittsburgh? I don't know how many are still. 300 steel-related businesses. What does the city feature? So these are perfectly reasonable things to get out of it. Now, what about bad questions? Okay.
What is Pittsburgh?
What is Pittsburgh? So is that possible? Well, Pittsburgh is a city. That's quite a good answer, isn't it?
I guess it's not really just finding what it's looking for, I guess.
But it's not a very interesting question. I agree with that, but it's still something that has an answer in it. Okay? And can somebody else give me an example of a question which is about Pittsburgh but isn't answered in this article?
What's the best college in Pittsburgh?
What's the best college in Pittsburgh? I wonder what that would be. Okay, but it's not mentioned here. So how are you expected to get it? Okay, so it's not really a reasonable question. At least you couldn't really write something that would generate that. Okay, although admittedly, you know, you could always ask the question of what's the best college in if it's a city, and know that cities almost always have a college. And but no, it's not that. So we're not looking at things that you know about Pittsburgh or things that you get externally from this particular article. Okay. Any other questions which could not be answered about this?
What is the Commonwealth of Pennsylvania?
What is the Commonwealth of Pennsylvania? It's mentioned here, isn't it? Yeah. But it doesn't say anything about what it is. Okay. How many Commonwealths are there in the United States? 4. Okay. I say this confidently because you don't know. Massachusetts and something. But it doesn't explain that. It doesn't go into detail. Okay. And although there is an is in the sentence, you couldn't really say the Commonwealth of Pennsylvania is the city of Pittsburgh, no, or is a thing that has city of Pittsburgh in it. So that is not good, okay? My first one nobody got. What's the capital of France? Okay, it's a perfectly reasonable question. It's just not appropriate. There's this rule: if you ever build a generalized question-answer system and it's not working, by default answer France, okay, or answer Paris, okay, because lots of people use that as their test sentence, okay, and so it's maybe only 1% are going to use it, but if you can't get your system working, you can always use Paris. So what's the capital of France is a perfectly reasonable question, but not about that article. What's the 57th letter of the article? I think all of you can write code to answer that question. I don't think you'll find that hard in any way at all. It is what's called not a reasonable question. Okay? Now, maybe in some other computer science class that is a reasonable question, but no. We're wanting things that are to do with the language from that point of view. Okay? What are Pittsburgh's 3 rivers? That might be a reasonable question, but it's maybe hard. Because what we have is located in the confluence of Allegheny and Monongahela rivers, which form the Ohio River. Okay, and so you have to be able to analyze that from different places. You couldn't just extract the information as is. You'd have to work out that there are 3 instances of things, and that Allegheny is a river. Okay, even though it doesn't have the word river next to it, so you have to know that Allegheny and Monongahela rivers, the rivers refer. So it's actually quite hard to do. It would be interesting to do, it would be valid to do, but it might be too hard. And that's okay. So what you're going to be doing when you're building these question-answer systems is you're going to be like hypothesizing how to get questions out of it and then be able to see if you get it right. And there might be some thing about this question you don't know, because remember it's fully automatic, because we could get other really weird things. Is somewhere. it's not sense. I can't immediately see one, but you can get sentences that don't make sense as questions. The Pittsburgh is a city is a perfectly reasonable external thing, but it's not a very sensible question to ask. What is Pittsburgh? Okay. So let's talk a little bit about how to fund questions. Okay. So what you can do is you can go and find patterns in the data where you've got X as Y. Okay. So you've got something is, and you've got some other thing. You know that therefore these two things are the same thing. And then what you can say is what is Y or what is X. Okay. But you have to know what, because it might mean, it might say something like Donald Trump is the 45th president of the United States of America, and you don't want to say what is Donald Trump. You want to say who's Donald Trump. Okay. And so you want to care about the object that you're talking about and get the right, what's called the WH word, so where, what, why, how, which isn't a WH word, but it is. It has an H and a W in it. And you want to find what the appropriate word is to be able to do that, given an X is Y. Okay, and so you need to have some sort of classification that we talk about a person, a place, a time, how to be able to do that. We can also look at X verb, Y, okay, and we can say what does the X verb, okay? So a little bit of manipulation that actually has to happen syntactically and able to do that. And there might even be something to do with the agreement of the verb and the object that you're dealing with, because in English we have agreement between subjects and objects, and so you might have to care about whether it's singular or plural, and so that's something that you do. Now, number-based questions are often quite good. Okay, what's the population? You get this number. What's the height of Mount Everest? Because it gives Mount Everest is something. And so these are usually quite good things to find. You can't always do it trivially, but you can usually work out if you're sort of right or not. Okay, so looking for numbers is another thing. So you look for is, you look for particular verbs, and you generate them, and you have to make a decision about whether they're good or not. Okay. We're probably looking for what's called extractive answers. So what that means is you're going to take a little piece of text that has got the question in it. You're not going to try and look across multiple. So you're not going to have questions, say, about an actor describe their early career. And then you've got to piece together the first 3 paragraphs of the Wikipedia entry about they were on a children's TV program, and then later they had the big break in a movie where they played the daughter of a superhero, and then they got their own TV show and became famous. Okay, that might be what their early career is, but it might be separated over 3 or 4 paragraphs, and you've got to try and piece these things together. These are hard. Okay, the best question and answer systems do not do that. At best, you would get here's a bunch of paragraphs that might have the answer in it, which you as a human can read and get the answer out of it, but it's not the answer. Okay, and we are caring about trying to get the answer. Okay, we're talking about mostly extractive questions and extractive answers, where we're looking for some string of words, maybe with a little bit of change, or maybe changing some of the order of things in it, maybe changing a little bit of agreement, caring about capitalization, but we're probably not going to do more than that, at least for first approximation. Okay. What we're doing with this project is we're getting all the teams to be able to build things, and you'll all generate questions. We'll then separate the questions and give them to other teams as well as your own team, and we'll run the system for everybody. And it's somewhat competitive, but only one component of the grade at the end is about how well you can answer questions. And so it's good if you can answer questions the other teams cannot. But if you can generate questions that nobody can answer, that's a waste of time. Okay, you won't get any points for it. Nobody else will get points for it. Okay, even if it's a good question. So you don't want to make the question so complex that you can't answer, and you don't really want to make the same question types that you can't answer. So you want to make sure you can answer it. And remember, you're getting completely new articles you've never seen before. They're going to be, in general, the articles are going to be in the same genre, so we'll give you a bunch of city, movie, philosopher. These are some of the classes that we've used before. And so it'll be in the same domain as that. And maybe you could even detect, is this about a city? Because there's certain city-type questions that are more appropriate, or ones about people, and so that might be appropriate. But in general, you don't know the article and don't know what it's about, so you can't over-tune it and it won't actually work. How do we evaluate whether they work or not? Okay? The answer is ultimately you're going to grade them. Okay? And so what we're going to do after we've run all the systems is we're going to get each of you to look at the answers, the questions and the answers, and make decisions about whether they're good or not. Okay? What do we mean by good? It's actually surprisingly hard. Okay? There seems to be two things that we care about when we're looking at questions and answers. One is fluency. How good is the English in it? Has it got some weird broken English thing? And so a little bit of broken English is fine, but if it's just nonsense, then no, that's not going to work. Okay? So we're looking at fluency, and we're also looking at reasonableness with respect to the questions. So is it a reasonable thing to ask a question about? Okay? What is Pittsburgh? If the answer is Pittsburgh is no, not good. Okay? Or who is Donald Trump? And the answer comes back is Donald Trump is our president. Well, that's true, but that's not the best way of describing it. Okay? So even though it might sort of be true, we want something more specific because there is something more specific and appropriate there. Okay? We also care about this rather weird thing. I know the press nowadays doesn't care about it anymore, but we actually care about something called accuracy. Okay? So whether you've got the right answer or not. I know that's a little unusual. We don't do that in the press anymore, but we will care about accuracy as well when you answer a question. Did you get the right answer? Okay? And so you'll have to know what the article actually is to be able to do that, because I don't think any of us know what the population of Pittsburgh is offhand. And really, when we mean it, we mean whatever that particular article said, which of course, I'm sure the population changes all the time. Notice that we're getting humans to do this, and humans are pretty expensive, okay, because they take a long time to do things, and you can't really put them into the loss function of your neural net and get them to test 100 billion examples every second on the GPU, because that's not what humans can do. And so it's good to have some automatic approximation of what humans do so that we can include that in our evaluation techniques. When you're running your code and you want to know whether it works, you'd like to be able to run an evaluation script that goes, yeah, I've now got 98% correct rather than the 96 I had before, rather than saying, oh wait guys, we have to evaluate this and look at them all. No, you can probably do something that's automatic that will be a good approximation of what humans do. It won't be exactly the same, but it will be an approximation and allow you to be able to work out whether things are doing. So we would like to know, which of your questions are best. Which of your questions are best? Okay, so we have a bunch of questions that generated, 250 questions from the article, and you have to give us 50 questions. You want to give your 50 most interesting, hardest, safest, something questions, and not take the ones that you think might be hard to answer, or inappropriate or not fluent. We'd like to care about the fluency, so you parse it and see how good it is in English. And that's a good idea. That might not catch things. It might make other funny errors. But one of the most obvious things that are perfectly reasonable grammatically from a parser, but are probably not a good idea, is if you have a question that has a pronoun and there's no antecedent for the pronoun. So if it just says, who is he? What? Without context, that's not a sensible question. Even though there might be somewhere in the article that says, he is the 45th President of the United States. Okay? But it's not a sensible question, even though it's completely grammatical. Okay? So you have to be aware of that. So like excluding things that have pronouns that, in fact, just excluding everything with pronouns in questions and answers is often a good idea. Okay, let's be a little bit more specific with question answering. The input's going to be a Wikipedia article, and we're going to give you a number. Okay, this is because we don't want you to only care about the first 5 or only care about the first 500. Okay, so we're going to give you some integer. Okay, and you have to generate that number of distinct questions about the article, which should be fluent and reasonable. So we're going to run a program that says ask, and your program is going to be called ask. And we're going to give the article in plain text, and we're going to give you some number. People keep asking us what that number is. That number will not be bigger than 2 to the power 23. Okay? It will definitely be smaller than that. The number will be positive. Okay? It will be bigger than 0, okay? Although one can imagine if we say minus 10, what it does is it grabs the next team's questions and deletes the first 10. No. Cool, but no, don't do that. It's going to be a reasonable number, but we don't want you to it is worthwhile caring about that. So you're going to write something that generates questions. You're going to have different classes of questions. And probably what you want to do is you want to look at that number, and you might say 10% of them I'm going to do simple WH questions, maybe 10% will be number-based questions, 10%. And so you're going to say, I've got these class of questions that I know I can generate. Let's actually distribute them through the whatever number is actually there. And that's a good thing to do, because you're going to have for each of the classes some better questions and some worse questions. And so that's a good thing to actually care about. Notice how naively we seem to be able to be talking about some command line thing to do this, okay, instead of some pointy-clicky interface. Of course it's going to be a command line thing. We can make it completely open to you of what language you want to program in, but it will have to run on our servers, okay? Over the years that we've run things or similar things to this, we've moved from lots of different languages to almost everybody uses Python. We don't require you to use Python, but almost everybody uses Python, okay? There's some programming language called Java that you might have heard of. Some people still use Java, and that's just fine, okay? It's not a problem. Sorry, I'm just showing my age. Even though they were both developed about the same year, although people forget about that, the popularity's changed. They're both in the mid-90s. But we are talking about a program like this, okay? Because that's sort of the easiest thing to do. We'll give you Wikipedia articles in 5 domains, okay? Some of these domains we'll identify beforehand. In fact, we'll give you examples of them. Some of the domains you'll have never seen before. There will be, we're not trying to trick you on this, okay? So we're not going to give you really weird articles that have references to other articles and they're just a link. No, they're going to be reasonable articles that we're given to you. You know, we're not trying to make that hard for you, okay? Yes, oh yeah. They'll all be English articles, okay, from the English Wikipedia, but they might not be from the current Wikipedia because we have some cached, okay? And we have considered making random changes to the Wikipedia articles that we then check to see that you're answering for this particular Wikipedia article, okay? Just in case you're caching things. So we might do that. However, although we're living in America and we know that Americans think that the whole world is written in ASCII, realistically these articles will contain Unicode characters beyond the ASCII character set, and you should care about that. The reason we say it, in fact, David and me, every lecture will remind you about that, is because it often breaks your code. All of a sudden you get an article that has a single Chinese character in it and it falls over. Or it's got a single accented character in it and your code falls over, because if you're not careful about dealing with strings, it breaks. So be aware of that. Do everything in Unicode. And realistically, you know, this is 2019, you should do everything in Unicode, okay? Because that's the way the world should be. It works very well. we'll give you some sample questions as well. In fact, you will generate, there's an early homework where you will be generating questions about articles humanly, no machines, so that you have some examples to play with. Okay? We choose N, you don't know what it is, that's because we don't want you to over-hack what it is, but it's somewhere between 2 and 2 to the 23 minus 1. Some of the articles you have access to, similar articles of the same kind. So if we give you a bunch of city ones, we'll give you some other city ones. And some of them will be completely different topic, a different genre. But they'll all be class, and they'll all be nice articles. We're not there to trick you. Okay? Each question will be evaluated on how fluent and how difficult. Okay? If you're good at answering a particular way of doing difficult questions, that's a good thing to consider. In fact, remember, we don't just measure how well your system performs when we answer questions from all the other teams, including your own team. We actually are interested in what you are doing. And therefore, you might want to spend some time on more interesting, complex questions and answering, even if you don't fully succeed in getting them to work all the time, because that's interesting. You don't want to waste your time only on that. You want to make sure you spend some time on the easy ones that everybody else is going to do. But if you do get some special types of questions and get them to work, okay, I don't know, getting pronouns to work so you can dereference pronouns within the articles and then use that information to be able to get more questions out of it, that's a good thing to do, okay? And we notice that and we care, okay, about doing these things. For answering, it's the same basic thing. What we're going to get is you get the text of the Wikipedia article and you get a list of questions that's been generated by you or somebody else. The output should be the answer to the questions. They should be one answer, one per line. There should be no output of your system whatsoever, because that confuses all of our automatic systems. There is this thing called standard error. You should learn about it. So that you don't print out information that gets mixed up in the answers. Where the answers should be fluent, correct, and intelligent human-like. Okay, so they should be something that a human finds reasonable. And you're going to say that's unfair because we can't quantify what a human finds reasonable. And the answer is yes, we can, because we're going to get all of you to evaluate the outputs and tell us whether you think you're reasonable. If you happen not to be human and you're in this course, okay, please pretend to be human when you're actually labeling that. And if you're really some AI system, then wait, shouldn't you be teaching us? But anyway, yeah. We'll give you some examples to play with. We'll give you some Wikipedia articles, and from the previous years, we'll give you some sample questions also from the previous years, and some sample answers of what we think the answers actually are, so that you can actually have something to test your systems on. This is going to be nowhere near enough to actually do training in the machine learning aspect of training. Is that a question?
Yeah. Do the answers have to be full sentences?
No. That's a good question. So if you say what's the capital of France, is Paris a valid answer, or do you have to say the capital of France is Paris? And the answer is Paris is okay, within reason. Okay. As I say, who's Donald Trump? And if your answer is a man, true, but weird. Okay. And I actually don't know, this is why we have to ask you, is who's Donald Trump? And the answer is president. Nothing else, just president. That's sort of weird. That might be right or it might not be right. It's not the best, okay? But it doesn't have to be classical sentences. But likewise, if you give an answer that's a partial sentence that contains the answer, that's not as good as giving a full clause. For evaluation, we'll feed questions in there. some of the articles, again, for the answering, some of the articles you've seen before, some of the articles you'll never seen before. Again, we'll select things behind the scenes for you to come up with reasonable form. And again, we'll be evaluating on fluency and correctness for the actual questions. Okay, so what do you have to do? Well, the first thing you have to do is form teams. Teams must contain 4 people, okay? And if there's not the right number of people, we have to press gang somebody else from some other class into this class so that we have a multiple of 4. No, we don't need to do that. Really needs to be 4. We really want it to be 4. If for some reason somebody drops during the semester and you end up with 3, we can live with that, but you really want to have 4. Not 5, not 2, okay? There are 2 sections to this class. There's the B section as well, the video section. You can mix between them and that's just fine. Not a problem whatsoever, okay? But you should decide what your teams are, okay? Your team must have a name, okay? And we've had to change the rules for the names every year because people always find ways to break it. And the answer is a Unicode string. Okay. Last year we had 2 teams called the Teletubbies, and they independently came up, and we didn't notice for some reason. It was really embarrassing. We didn't notice until near the end, and we thought, wait, I thought there was another team called that had, and it's like, no, there were 2 teams. So be aware that you've got a bunch of people who are roughly the same age as you, who have got limited views of the world that they come up with. We have to make the thing that they write it down not allow the names that are confusable. Okay, it would help if the name is pronounceable in standard English. Okay, but given that both David and me are fairly good at phonetics, surprise us. Not a challenge, not part of it. There's no prizes for making us change the rules of the names of teams in future. Okay, so we want we want the names, and we want your. And another thing about please, in any of the presentations and everything, make or reports that you do, that you identify your team name. Surprisingly, people don't always do that. And the members of your team. Okay? Also be aware that many of you have multiple names. Okay? Not just family names and given names, but sometimes you might have a native name and you might have an English name. And you use one and use the other, and the university knows about it. And this is really hard for us when we're desperately trying to work out, wait, is this the same person or a different person? And there might even be people in the class who have the same name. Okay, this does happen. So, because we're a bunch of computer scientists, we need your Android IDs on these things as well. Okay, because we hope that that's unique. Okay. One of the first tasks you probably want to do is build a question generator. Okay. You probably want to develop the question and answer thing at the same time, because you don't want to build a whole question generator that you can't answer. And you don't want to build a whole answer thing where you can't generate questions. Because you'll discover when you generate questions, your good ideas are not as good as what you thought they're going to be. And it's quite hard to do reasonably reliably. And therefore you'll find out what questions are, and you can find out which ones you can actually answer. Okay? Here is a potential way to build a question generator. Okay? You're going to get the article, you're going to analyze it, okay, and you're going to segment it into sentences. Okay? Now, what you discover in Wikipedia and in any real text, that the definition of sentence is not as good as what you were taught when you were in elementary school. And there's a lot of questionable decisions about that. Now remember, the article will have headers in it that are probably not classical sentences. They don't have a subject and verb. And so maybe you want to identify that and exclude those, okay? Because they're not good for generating questions. Many sentences will have a period or a full stop at the end. These are the same thing. But be aware that there might be periods and full stops after abbreviations as well. Doctor, like DR, doctor. Okay? But you're going to have to come up with some way to actually do that. There are toolkits out there that help you do that. They're probably not going to be 100% correct, but that's okay. They don't need to be 100% correct. They need to be good enough. Okay? And most simple sentence segmenters usually do things in the well in the high 90s and will get screwed up sometime. You get a table in there and it gets utterly confused. Okay? You may then want to try to work out for each of these sentences, and you maybe want to do things like get rid of the really short ones, the one-word ones, and get rid of the ones that have got 4,000 words in them. They're probably not sentences, they're probably some table or something weird. Just don't touch it and get rid of them. Okay? We'd like to find out what the words are, and all of us think we know that that's really easy. It's just the space-separated forms, and the answer is it's not quite right. Okay, there might be URLs, there might be links in there. You may want to get rid of the punctuation, you may not want to get rid of the punctuation, you may want to separate the punctuation off into another word. All of these are possible, and so there are also things that are out there that will help you do that. You may want to run some sort of part of speech tagger on it, so you know which are the nouns and which are the verbs. There exists very good part of speech taggers available in a number of toolkits, particularly NLTK, Python toolkit, or the Stanford Core NLP tools, which is in Java, although it has Python wrappers as well. These are very good. You maybe could do better than them, but that's not what this project's about. So you probably just want to use these tools to be able to get it. Because it's useful, because then you could start doing things like don't take anything that's got longer than 6 nouns in a row, because you know what it is, and some sort of normalization for that. You could go and find every occurrence of the word is, okay, or some other simple verb does, something like that, okay? And then what you could do is you could replace the subject with an appropriate word, okay? Where, why, what, who, when, okay? The why is really hard. Don't do it, okay? It's just really hard, okay? But the who and the when and the what and the how much are quite good to do, and they will often work, and you'll be able to work out and get a classifier that will work fairly well most of the time. And so you might actually want to come up with a classifier that works well most of the time. It knows when it doesn't work. So it says, I don't know. And then you shouldn't do that as a question. Okay? So you should be conservative on the things that you're actually generating. Okay? Simple rules get you a little bit on the finding the right word, okay? Using your simple rules to be able to get some data out of it is a good idea, and then you, by hand, go through and find all the errors and correct them, and then you can try to build a classifier that looks at all the data that you have. It will learn the rules, probably, and it will learn the funny exceptions to the rules given the data. And that's a good way to actually go about doing this iterative improvement on things, making sure you're always testing on unseen data, or at least data that you're not looking at the output in hand fixing. Okay? Being able to recognize errors and thresholds is a lot of what this is all about. It's a lot of what NLP is about. If you actually want to use things, there are lots of things in NLP that are fairly reliable to work. Okay? But there's a whole bunch of things that are incredibly hard, and they're just beyond our current technique. And if you can work out when you've got down to the level where it's not sure, then don't do these things, okay? We won't really be asking even 10 to the 22 number of questions, so you don't have to generate a billion questions. So it's okay to be conservative on the questions that you're actually generating. Once you generate these questions, you should come up with some evaluation criteria. Okay? How can you tell whether it's good? How can you tell when you see an error and you fix your program that it's better? Okay? Now, I know you believe that when you fix a bug in your program, everything gets better, But no, that's not the right criteria, okay? You want some way of automating your evaluation, or at least structuring your evaluation. And it might be you have your test article, you run it, and you, as a human, or one other team member who didn't write the code, okay, makes a decision so they're not influenced by the things that the code do, go through and look at the 100 that got generated and find the best 50 and keep them as the best 50. And then what you want to do is every time you run your code, you want to make sure that you get at least some number of that 50. And maybe that's a way to evaluate that. You find out whether you get 36 the first time, you do some things, improve things, you get up to 42, and then you're doing well, okay? And so that's a good thing to do, to have some automated way of finding out whether you're getting better. And much more importantly, you're not getting worse, okay? Because as we all know in correcting programs, you can correct a program and it's now right, and it's worse, okay? Not good. And so you want to know that. And you want to have an automatic thing. Now remember, what's going to happen at the end of the semester is we're going to give you access to one of our servers. You're going to install the system on our server, and you're going to find out whether your system works or not, okay? So you want to have an automatic test thing that actually runs and gives the output that you expect. So you want to have known articles that are in your test set with known answers that you expect to get, and you want to evaluate to see whether you actually get it on our servers when you get it on yours. You might think that's trivial, but it's surprisingly hard, and people get caught out with it every year where they end up using our servers, and even though our servers are exactly the same version of Ubuntu, apart from there's different packages on it, and you thought everything was the same, but you know, because our servers are based in the southern hemisphere, the electrons are going the other way around, and therefore you get a different result. Okay, I'm joking about the electrons going water and toilets. But it's surprisingly what can be different now that you don't expect, so you want to have something to do. You know, you've got some randomness that chooses things, and the rand function is different on the different machines, as it should be, but maybe it's not what you expect. Okay? So always building your code, you all know this, with some form of make test in it, so that you can actually confirm that everything's still working. It's a really good thing to do. And you will need to do it when you're doing the driver on it. Okay, before I get on to these things, one of the things that you'll be doing, so there'll be a number of stages in the project. There's sort of replace projects when it actually happens. There'll be an initial stage where we expect you to actually build something and get a pipeline. We usually get you to do something like count the number of nouns in the article, which means you have to get some sort of switch standing working. There is a report due mid-semester, which is both written and a video. So what we do is we get you to select videos through YouTube. There's a meeting that you'll have with the TAs and the professors where you'll tell us what you're doing. We have that mid-semester as well, usually just after the spring break. And then at the end, after you've done the actual evaluation when we run it on our servers, there's another video that gets given that gives an overview of what your whole system actually is. And what I'm going to do now is I'm going to play one of the previous year's videos to show you what the type of video is, and admittedly how they did it, so you get to see some of the techniques that they're actually doing. Okay. I have to work out why the audio actually.
We designed and implemented our question generation and answering system. Our goal was to create. Hello everyone, this is Emily and Jeffrey from Team Super Firewall Unicorns, here to discuss how we designed and implemented our question generation and answering system. Our goal was to create a program that reads a Wikipedia article and understands it well enough to generate and answer questions. When we started this task, we imagined a system that would extract factoids from the text into a database. Both our questioning and answering systems would draw from this pool of knowledge to complete their tasks. However, we realize that this sets a hard limit on the types of questions we'll be able to generate. So instead, we directly manipulate the syntactic structure of the article to form questions. However, this assumes that the article is long enough to have the syntactic structures we like. Now, in order to answer questions, we perform fuzzy matching between the sentences in the article and the questions. This allows us to identify potential answers from the best matched sentences. This method is based off the assumption that, since questions are fluent and reasonable, the questions will contain a lot of semantic words. Here's how we implemented the system. We start by pre-processing the article. We split the article into sentences and then take each sentence and tokenize and parse it with a Berkeley parser. This gives us a parse tree and a probability for each sentence. In addition, we run the Lancaster stemmer over all the words and then create sentence vectors based on the count of each word. We treat each sentence in the article as a document to compute the inverse document frequency of each of the stemmed words. This assigns a higher weight to more significant or rare words. What we'll do with this will become clearer when we discuss the answering module. But first, we'll explain how the asking module works. After pre-processing, we have a collection of sentence parse trees. We remove trees that are no good for question generation, such as if they're too short, if they have no verbs, or if they have too many pronouns. Co-reference resolution doesn't work very well, and so by avoiding questions with pronouns, we avoid generating awkward questions, even if those questions could contain important factoids. Now, whenever we have a sentence made up of a noun phrase and a verb phrase, it's like an informal factoid. The subject noun phrase satisfies the predicate verb phrase. But wait, there's more. There are more patterns in syntax that can express semantic relationships. For example, if we find two noun phrases separated by a comma, those noun phrases are usually describing the same thing in two different ways. So we can transform this subtree into the sentence, noun phrase 1 is noun phrase 2, and add it to our pool of sentences. We have a bunch of hard-coded pattern matching rules like this that give us a lot of new sentences to generate questions from. There are two major types of questions that we can generate: yes-no questions or identification questions. Who, what, where, when, which, why, how. To generate a yes question from a sentence, we 1. Augment the central verb with a modal verb. 2. Move the modal verb from the middle of the sentence to the front. And 3. Add a question mark. To generate a no question, we take a yes question and corrupt a random word in hopes of changing the meaning of the question. We can mutate common nouns by finding their hypernym in WordNet and then finding a hyponym of that. We corrupt proper nouns by swapping them with another, and we literally fudge numbers by multiplying them with random factors. Generating WH questions can be trickier. We run a supersense tagger over our source sentences. It's like a name entity tagger, except words are tagged with their WordNet class. This way, we can identify people, organizations, locations, durations, and objects, and replace them with a corresponding question word: who, what, where, and when. We usually only replace an entity if it's the first word in the sentence, which maintains the grammaticality of the sentence. After we've generated a large pool of questions, we score the questions with 3 main goals. Is the question reasonable, fluent, and intelligent? To make sure questions are reasonable, we penalize questions that are too short or too long, or have negation words in them, since those are usually confusing. We give bonuses to prepositional phrases, since those add context to questions. Next, we score the questions based on how fluent they are. To check for grammatical correctness, we use a question tree bank to train a grammar of English questions for the Berkeley parser, as if we were working with a foreign language questionese. This allows us to retrieve the probability that a string is an English question, which is more useful than just determining if the string is valid English. But how do we tell if a question is intelligent? There are no stupid questions, or so they say, but we think that a good question should have a good answer. So, we run our answering system on our questions to make sure that questions with good answers are rewarded. Finally, after we've scored all of the questions, we choose the best end questions and return them. So what exactly is in this magic answering box? Remember how we turned our articles into bags of weighted stems? Well, where we compare an input question with all the sentence tags in the article using cosine similarity NTF-IDF to find the closest matching sentence. The most similar sentence to the question becomes our answer source. For identification questions, we need to narrow down the answer within that sentence. Step 1. Identify the question type. Step 2. Supersense tag all the things. Step 3. Looking only at the words that are not in the question, find words whose sense tags match the question type. Step 4. Return the smallest parsed subtree containing those words. Finally, for yes/no questions, we see if all the important words in the question are also in the answer source. If not, probably something fishy is going on, and we say no. Otherwise, the question seems pretty reasonable, and we say yes.
Okay, so there's a pointer to this on the website, or there will be by the end of today, so you can actually go through it. It mentions a whole bunch of things that you probably don't know yet, which is good, because we're going to teach you those things. They did, that team, I don't think won that year, but they did very well, and their presentation was particularly clear, and that's why we show it. Let's add a little bit other constraints where you have to be aware of these things. When you're running your system, you're not allowed to use an external system to do things. Okay, one of the things you could do, and it would probably work quite well, is for every question you get, is to give it to Google and get the answer from Google, okay, and give that as a response. One of the reasons why that's quite good is that people who do question answering at Google used to do this course. So we taught them how to do that some time ago. And the other thing is that people at Google know that you're doing this course and this project, and therefore they will identify you if you send too many questions about Wikipedia articles. Actually, they don't. But they do know, and there are people on question answering at Google who used to do this course. So you're not allowed to do that, obviously. The point is, you're writing your own question answering system, so you can't use somebody else's question answering. And there are other question answering systems out there, but no, you're not allowed to do that. You are allowed to use other tools, though, and we expect you to use other tools. The purpose of this is to find the tools and to put them together that give you parsers, that give you named entity labelers, that give you part-of-speech taggers, that do tokenization. All of these, we expect you to be able to do that. And these set of tools that are already out there, you're probably going to use those. And that is absolutely fine. If we have a homework where you have to write a part-of-speech tagger, we don't, you would not be allowed to use somebody else's part-of-speech tagger. Well, you could, but you wouldn't get the grade, they would get the grade, and so on the same. But in the project, we are expecting you to use these toolkits and not write things from scratch. But it's not just a matter of putting these things together. There'll be more work than just putting them together. But you are allowed to bootstrap and use these systems in order to be able to build your system. Okay? What's important is that you build your team as soon as possible and decide how you're going to communicate and actually try to have things done each week rather than wait to the end. It's surprisingly, you might think it's freezing cold outside, but don't worry, soon it's going to be ridiculously warm and it will be the end of the semester and the project will be due. But we do have deadlines on the way to make sure that you don't leave it right until the end. Okay? Oh yeah, evaluation, make sure you have your own evaluation function. I always say that to the teams and I'm always right. Because if you have that, it'll make your life. You might have to change your evaluation function regularly because you get better or you do something else, but that's okay. But you should just always have an evaluation. All of you should have access to the website by now. Okay, if you're still on the wait list, there could be a problem. Okay, in that you're in too many courses, and we have tried to let everybody in that we can. we're going to move people who are in section A into section B. Okay, if we can't get you into section A, section B is video only. But towards the end of the semester, usually there's enough space and you can come to this, or you can just watch the video. Okay, that's just fine. The quizzes that we'll be doing regularly are there to ensure that you're picking up with what's happening on the videos and the lectures, to make sure that you're at least seeing them at some point. A team name, 4 people, really do 4 people. It's a big project. You really want to try to share the load amongst people. If you're less than 4, it is harder, and if there are more than 4, some people won't do their job. So please try to get 4 in your team. If you can't find 4, or you have too many people, come and see the TAs and we'll arrange to be able to separate some of you off, or find other people. The teams aren't complete, and we'll do that. You want to make sure that you get contact details from all of your team and find a way to be able to communicate. It is a good idea to have a shared GitHub or equivalent way to share code. It's a good way to do it. GitHub allows you to have an infinite amount of private projects these days, so you should make use of that. It's a good way to be able to share information. But there should be some way of doing it so that other people can get the code and see what's actually changing and test it and make sure that things are actually working. Okay, that's it for today. Are there any questions about the project?